today we are discussing the transformer testing. Most of the transformer testing we have discussed in the previous lecture. The remaining transformer testings are routine test of transformer. This type of test is done this type of done to check their quality, reliability, proper working with stand before they are put into the service. So, these tests are conducted on each individual transformer unit during the manufacturing process or commissioning. So, here are the some of the common tests, routine test. That are the winding resistance, insulation resistance, temperature rise, short circuit withstand and the transformer oil test. The last two we will discuss further because the previous we have discussed. So, short circuit testing, just check the stress in which are caused due to the short circuit faults in the electrical system. So, primary purpose of the short circuit test is to evaluate the mechanical strength and the safety of the transformer under the abnormal condition. So, this test generally performed at the time of manufacturing and the testing of the transformer. So, the following are the purposes of the short circuit withstand test. Number 1, just to determine the mechanical strength of the different components of the transformer under the short circuit fault condition. Then the heat dissipation ability of the transformer during the short circuit fault can be measured. Weakness or deficiency in the transformer design or the construction can be measured by using this test. So, moreover, to detect the safe operation of the transformer under the adverse conditions can be checked by using this test. So, the short circuit withstand test procedures are as follows. First, ensure the all connections in the primary and secondary windings sides are properly configured and connected. Another is the contact the high current sources such as short circuit generator or the specialized short circuit testing devices to the primary winding. The next step is apply the short circuit current to the transformer's primary side of the required duration and monitor the current waveform and magnitude throughout the test. After that, analyze the observed data to evaluate the transformer performance during the test. So, the data that is we can check through the short circuit withstand that will evaluate the transformer performance during the test, we can do it. Another is the transformer testing that in the transformer testing, the another test is the transformer oil. So, the transformer testing, the transformer oil test is done to check the health and performance of the transformer. So, in transformer, oil serves as a multiple purpose, like it is used as a insulation, used for the cooling, and it is used for the arc suppression. So, that we can measure through the transformer oil testing. So, over time the quality of the oil degrade due to the various factors such as the moisture, oxidation and the contamination, which leads to the result in reducing the efficiency and the reliability of the transformer. So, the following are the main purpose of the impulse voltage withstand test is the just check the dielectric strength of the oil. So, which is important for evaluating the insulation purpose of the transformer. So, moisture content of the transformer can be determined as the moisture is the common contaminant in the transformer oil, which can lead to the degradation of the insulation of the transformer. So, to determine the acidity level in the transformer oil and excesses of its neutralization capacity that we can measure through the transformation this oil testing. So, insulation degradation, which can help to analyze the gases dissolved in the oil, which provides the insight into the internal and the potential issues in the transformer. So, how we do the transformer oil testing? First, collect the transformer sample of the transformer oil using the proper sampling techniques. After that, check all the testing equipments in the clean and calibrated according to the testing requirement. After that, set up the test cell with electrodes and place the oil sample between them. After that, applying the increasing voltage to the oil sample until breakdown occurs, recording the voltage at the breakdown, means at what voltage breakdowns occurs, that will be measured. After that, determine the acidity level of the oil by measuring the amount of potassium hydroxide, that is KOH, required to neutralize the acidic components. After that, analyze the test result to evaluate the dielectric integrity and the oil condition of the transformer. So, these tests can be done for the oil testing. Another test is the special test of the transformer. So, what is this special test of the transformer? It is done under the specific circumstances on when particular issues regarding the transformer's performance, condition or the application. So, these tests are not be part of the standard manufacturing of commissioning procedure, but are carried out as needed to particular issues or to check the transformer continued safe operation. In the special test, it includes such as partial discharge test, which detects the insulation defects or the weaknesses of the transformer. Impulse voltage withstand test to check the transformer's ability to withstand high voltage impulses. Frequency response analysis to detect the mechanical defects or winding deformation in the transformer core and winding by checking their frequency response to a frequency signal. So, in the pre-commissioning test of the transformer, and it is done before the connecting the transformer to the electrical system. So, these tests are done to check the transformer is installed correctly and it is in good working condition that meets with the required standard and specification. So, these tests include the visual inspection to visually inspect the transformer, polarity check to verify the correct polarity of the transformer windings and connections, insulation resistance test to measure the insulation resistance between the various parts of the transformer, and in the winding resistance test to measure the resistance of the transformer winding to ensure they match design specification and estimate the copper losses as well as the turn ratio, test to verify the turns ratio of the transformer and ensure the correct voltage transformer. So, these type of tests are done for the transformer testing. So, these tests are very important whenever we just take the transformer, when we install the transformer, when after installing the transformer after 1 year or 2 years, there is a requirement of the maintenance of the transformer. So, all these tests done at the 3 levels. So, now we discuss the one of the important transformer, which is the 3-phase transformer. In the single phase and the 3-phase, we will discuss what is the difference between these 3-phase and the single phase. First, we discuss the 3-phase, that is the 3-phase electrical system is used to generate and transmit the electric power over the long distances for the use by the offices and the industries. So, these 3-phase voltage, or we can say it is a 3-phase current transformer, are raised or lowered by means of 3-phase transformer. Means by using this 3-phase transformer, voltage or current can be raised or can be lowered by means of some action. So, since a 3-phase transformer can have its winding connected in the various way. So, that we will discuss further. So, thus far as we look at the construction and operation of the single phase 2 winding voltage transformer, which can also be used increase or decrease its secondary voltage with respect to the primary supply voltage. Means by using the 2 winding voltage, that is a single phase voltage, which can also be used to increase or decrease its secondary voltage with respect to the primary supply voltage. But voltage transformers can also be constructed for connection to not only one single phase supply, but for connection of the 2 phases or the 3 phases, 6 phases, even more elaborate combinations up to the 24 phases for the some high power DC rectification application. So, we take 3 single phase transformer and connect their primary winding to each other and then their secondary windings to each other in a fixed configuration. So, we can use a combination of the 3-phase supply. So, 3-phase supply, also written as 3-phase or the 3-phi type supplies, are used for electrical power generation, transmission and distribution, as well as all industry or as well all the offices or the houses. So, 3-phase supplies have many electrical advantages over using the 3-phase power. But considering the use of the 3-phase transformer, we have to deal with the 3 individual alternating voltage and current differing in the phase time by 120 degree, as you see in the diagram. So, 3-phase voltage and current which is changed as 120 degree angle. So, here you see VL is equal to root of 3 Vp, this we can say. So, where VL is the line to line voltage and Vp is the phase to neutral voltage. So, we can note in this transformer that it cannot act as a phase changing devices, but changing a single phase supply into the 3-phase. So, a 3-phase supply into a single phase. So, vice versa can be done to make the transformer connections compatible with the 3-phase supplier. We need to connect them together in the particular way to form a 3-phase transformer configuration. So, the 3-phase transformer can be constructed either by connecting together 3-phase transformer, thereby forming a 3-phase transformer bank, or by using a pre-assembled and balanced 3-phase transformer. Either we can combine the single phase into the 3 part, and or we can have the we construct the balanced 3-phase transformer, which consists of 3 pairs of the single phases winding mounted onto one single laminated core. So, the advantage of building a single 3-phase transformer is that for the same kilovolt ampere rating, it will be smaller, cheaper or the lighter than the 3 individual single phase transformer connecting together. So, this is because the copper and iron core are used more efficiently. So, the method of connecting the primary and the secondary winding are the same. So, whether we are using just the 3-phase transformer or the 3 separate single phase transformer. So, you can see in the circuit there is a 3-phase transformer connections. So, 3 single phase transformer. You can see here we are defining the core, and the left hand side we have a primary and right hand side we have a secondary AP, AG and in the another BP and BS. BP is primary, and BS is the secondary. APAS, BP, BS, and then core. For the C1 is the CP and CS. Right hand side you can have the various symbols that define the primary configuration, and right hand side we have the secondary configuration. If we have the delta mesh, then it is a triangle type. Delta mesh, we have a triangle type, but in the right hand side delta mesh, and second is the star that defined as a Y. So, star defined by Y, and another is the interconnected star that is defined on the last point. So, three types we have: delta, star and interconnected star. So, the primary and secondary winding of the transformer can be connected in the different configurations just to meet the practically any electrical requirement. So, in case of the three phase transformer winding, three form of connections are possible. Number 1 is the star, that is Y. Number 2 is the delta, that is the mesh, and third is the interconnected star, that is the zigzag form. So, 3 we are having: star, delta and interconnected star. So, the combination of the three windings can be with the primary winding delta connected and the secondary winding star connected. Number 2, star, delta, star, star, delta, delta. Means we have the three windings. Number 1 is the delta connected with the star. Another is the star, delta, star, star and star, delta, depending on the transformer which we are using. So, when transformer are used to provide the three or more phases, they are generally referred to as the polyphase transformer. So, polyphase transformer which just use three or more phases, that is a polyphase transformer. So, three phase transformer having the star and delta configuration. First, what we do mean by the delta, that is known as Y. Delta is star as a Y and delta as a mesh, which dealing with the three phase transformer connection. So, the three phase transformer has three sets of the primary and secondary winding, which depends upon how they set of the winding are interconnected. We determine the connection in the star and delta configuration. So, three available voltage which themselves are each displaced from the other by the 120 electrical degree. The three available voltage which themselves are displaced by 120 degree angle. So, not only decided on the type of the electrical connections used on the both the primary and secondary side, but it determines the flow of transformer current. So, with three single phase transformers connected together, the magnetic flux in the three transformer laminated core differ with the phase by 120 time degrees. So, these three single phase transformer which we are connecting together, the magnetic flux in these three transformer laminated core which is differ in the phase with the 120 degree angle. So, the standard method for making a three phase transformer winding is to label the three primary winding with the upper cases like letter A, B, C. So, these capital letters are used to represent the three individual phases of red, yellow and blue. So, the secondary winding are used labeled, but the small letters. In the primary we use the capital letters A, B, C, and in the secondary we use the small letters, that is A, B, C. Each winding has the two ends normally labeled 1 and 2. So, for example, the second winding of the primary has ends with the labeled B1 and B2. So, each winding has the two ends normally labeled 1 and 2. So, B1 and B2 is defined for the primary, while the third winding of the secondary will be defined by the C1 and C2. You can see on the screen transformer, stars and delta configuration. So, you see on the screen that how it is defined as. So, it is easy to understand that A, B, C, these are the primary, and then A, B, C small are the secondary. This is left hand side, it is converted into the star, and right hand side it is the delta connection can be done. So, right hand side you can see the star connections and delta connection. In the star connection you see that is a all are connected with a single point, that is a end point. A, B, C are connected with a single point, and in the delta A connect A, B, C are connected, then we have a 3 points after the connection A, B and C. So, this is the delta and star configuration. Symbols are generally used on the 3-phase transformer to indicate the type of connection used, with the upper case is Y and the star connection that is defined by the D. D for the delta, Y for the star. The letter Z represent the interconnected star primary winding. So, in the lower cases we have the Y, D, Z for the respective secondaries windings. So, a star connection 3-phase transformer would be labeled as capital Y and the small y, delta delta, capital D, small d, and the interconnected capital D and Z, capital Z and small z for the same type of the connected transformer. Y for the star transformer, delta for D for the delta transformer, Z for the interconnected star. Now, you can see on the screen, this is a transformer winding identification, connection, primary winding and secondary winding. This is very clear, delta D, capital D, and the secondary winding have a small d, star having the Y, capital Y, and the secondary winding have a small y. In interconnected, we have capital Z and the small z. So, we know there are the 4 different ways in which 3 single phase transformers may be connected together between their primary and secondary 3-phase circuit. So, these 4 standard configurations are delta delta, D star star, that is Y, star delta, that is YD, and the delta star DY. All the combinations we can take, these are the 4 combinations, delta delta, star star, star delta and delta star. So, transformers for high voltage operation with star configurations have the advantage of reducing the voltage on an individual transformer. So, thus reducing the number of turns required and the size of the copper conductors, making the coil winding easier and cheaper to insulate them. Delta configuration transformers. So, delta configuration nevertheless has one big advantages over the star delta configuration, in that if one transformer of a group of 3 should become faulty or disable, the 2 remain ones will continue to deliver the 3-phase power. If one is damaged, then other 2 will work, then it will supply the power. So, with the capacity equal to approximately 2/3 of the original output from the transformer unit. So, the transformer delta and delta connection, you can see on the screen, the transformer delta and delta connection. So, you see here there is a tune ratio and we are having a delta delta connection. If one way, then a delta delta transformer connections are defined in this diagram. Primary winding, and then at the lower side we have the secondary winding, the values are given. So, we have connection A and BC, and here we are having a ABC. In the delta delta connection group of the transformer, the line voltage VL is equal to the supply voltage, that is VL is equal to VS. But the current in each phase winding is given as 1 by root 3 into IL of the line current. So, IL is the line current. So, the voltage VL is equal to Vs, but the current is 1 by root 3 into IL. One disadvantages of delta connected 3-phase transformer is that each transformer must be wound for the full line voltage. And as an example, above 100 volt, 57.7% line current we will get. So, the greater number of the turns in the winding together with the insulation between the turns necessitate a larger and more expensive coil than the star connection. Another disadvantages with the delta connection 3-phase transformer is that there is no neutral or the common connection. And if we talk about the another star arrangement, each transformer has one terminal connected to the common junction or the neutral point with the 3 remaining ends of the primary winding connected to the 3-phase supply. So, the number of turns in the transformer winding of the star connection is 57.7% of these required for the delta connection. So, the star connection requires the use of 3 transformer. If any one transformer becomes fault, then the whole group might become disabled. So, another will not work. So, these are the type of 3-phase transformer. In the next lecture, we will continue with the single phase and comparison between these 3 phase and the single phase transformer. Thank you very much.